The global epidemic of AIDS is caused by HIV infection. HIV, short for human immunodeficiency virus, is a tiny infectious particle carrying RNA as its genetic material.
Once these virions invade human bodies, they hijack one type of immune cells, multiply like crazy, and eventually destroy the immune system, leaving the infected people vulnerable to other infections. By studying the infection mechanism and life cycle of HIV, scientists have developed several drugs to fight them.
Surprisingly, one of the most important findings in helping us fight HIV infection is based on a simple math model.
If a patient is treated with drug A, for example, at first the number of viruses in the body decreases exponentially. However, some drug-resistant viruses will emerge and eventually repopulate the patient's circulatory system, making the drug ineffective. Drug resistance is due to a mutation to the genome of HIV. The mutation rate of HIV is 1 out of 30,000 per nucleotide per replication cycle. In other words, for every 30,000 newly produced viruses, one virus has a specific mutation that makes it resistant to the drug. If we consider that several mutations that occur to different sites of the HIV genome may cause the same type of drug resistance, the actual probability is even higher. To simplify, let's say 1 out of every 15,000 viruses are resistant to drug A. Even in the latency phase, inside a patient, 10 billion viruses are produced every day, out of which about 700,000 are resistant to drug A. That's a lot. No wonder one drug never works. What if we use 2 different drugs at the same time? The chance that a new virus has the exact combination of mutations that make it resistant to both drug A and B is much lower, around 1 out of 15,000 squared. Out of the 10 billion new viruses, only 44 are expected to be doubly resistant. That is much better, but not good enough. Things are different if we use 3 different drugs at the same time. The probability of generating a new virus that is triply resistant is 1 out of 15,000 to the power of 3. Out of the 10 billion viruses produced every day, only 0.003 is expected to be triply resistant. Now we are much more comfortable with that number, and it works.
Today, a 3-drug cocktail is a gold standard treatment for HIV infection. Amazingly, a simple math model helps turn a global epidemic into a chronic, manageable condition.